Today we're going to talk about arrays, working with arrays in GoldSim. So there are quite a few basics that I wanted to cover, and the goal here is by the end you should be able to use arrays of various sizes and shapes and work with them, and also be able to use the very important function called a vector constructor, vector or matrix constructor. And this by itself is very compact and very powerful function, but there's a lot that you should be aware of before you dive into that. So that's what the hope is of this webinar, is that you'll have enough background information to use that comfortably. Okay, so arrays in GoldSim are set up using the array label sets. An array label set is accessed up here in the model menu under array labels. When you go to this array labels dialog, you'll see that you can add a new set. By default, all GoldSim models come with two that are already there. These are both called named array label sets, and you can see that the range here is based on names. If I click on the edit set, then you'll see the names of the week for the days array label set. Notice I can change the order if I click on move up. Obviously we wouldn't want to do that for this particular array label set, but you could do that for any that you wish. Also, you can change the line styles based on a base style. The base style is always the first one. You can have the lines vary by only color, or vary by only style, or by symbol. So that gives you some options. If you only have a few lines, 10 or less, you probably are fine just by varying it by color. GoldSim uses an internal algorithm to determine what those colors are. But you can change any of these if you want to be your own style with symbols and line type and thickness and all that. The show column here is a way to define by globally for all charts, all of your line plots and all of your bar charts, etc. Anything that shows the results of this array label set, or outputs with that are defined using this array label set, will show only the outputs that have a check mark in this checkbox here. So we could not show all Tuesday results in your entire model by unchecking that box there. Oh, and that was going to show you indexed. So back to the array label sets. If I want to add a new set, I could add a new one called indexed set here. Let's call this housing type, and I might have 3 different types of houses in my model, and so I would set it up something like this. And now you can see it's not named 1, 2, 3, and also notice there's no way to change the order. That wouldn't make sense for an indexed array label set, because they need to be indexed with numbers that are in order. Something important about array label sets is that they must be consistent when you're copying and pasting. So to get to that, let's talk about the definition of some GoldSim elements that are defined using the array label sets that we have available. So I'm first going to start by creating a data element here. By default, data elements, most elements in GoldSim in fact, are scalar, meaning they are only one value. So as you might recall, we can put in a number here, we can put in a unit, millimeters per day, let's say. And now when I hover over this element, you see it's just got the one value. Then we can add another element here. In fact, you know what, I'm going to change this unit because it doesn't make a lot of sense for the array label set that I have here. All right, so now I'm going to copy this, and I'm going to call this vector data. And let's change this from a scalar to a vector. To change it, you can click on the Type button here, and now it allows you to look at changing the type, which we're not going to worry about, but the order is what we're interested in. And we can change it to a vector. In GoldSim, a vector indicates that it's a one-dimensional array. When I select this, then it asks me what the row labels are. And with GoldSim, when you have a vector, it's always rows that it's talking about. It doesn't really matter. It's just the number of items that are in that array label set. But the way that it appears in a table looks like rows. So that's why we have it row labels there. Okay, so I'm going to say, I could say housing type here, but actually what I want to do is create a new array label set. So I can do that either through that menu I showed you earlier up in the model menu, or I could do it right from here. If I can just create it on the fly. So I can hit create labels, and now I'm back to that same array label set definition property page that I was at earlier, and I'm going to hit add a new set, and I'll do another name set, and I'll call this fixture type, and I'll add a few fixtures here. So shower, sink, dishwasher, and toilet, like that. Now that I have that defined, GoldSim will add that to our row labels definition. And now, instead of having one single field to edit data in, I can click Edit Data, and now you see I have 4 different fields to put in here. Notice that if I go back to our array label set definition, and if I change the order here, so I'm moving dishwasher down to the bottom, when I go back to the data itself, you'll see that it has moved, and the value that corresponded to the name has also moved. We can create a matrix data too. This is a 2-dimensional array. And I'll make this fixture type by housing type. Now you see we have all of these same values. Like that. When I hover over the non-scalar elements, you see it shows me all the values up to a certain point. These are small enough that it will show you all of the values with the tooltip, but if they become much larger, then it just truncates what it shows you there. Okay, I'm going to open up a new instance of GoldSim here. Put these side by side. Let's go to this new model and look at the array label sets. Notice we only have the originals that I showed you earlier and nothing else. I'm going to save this model real quick here. If I copy this data element, the matrix, into the new model, and then go back up to the array label sets, you'll see that those were added. The housing type and fixture type are now in there. Now if I come into the fixture type and I change the order here, then if I copy and paste this vector, and let's remember what the values are here. Notice for dishwasher it says 3. Okay, if I copy and paste this into here, let's open this one. Now you see the order there. If I open this, you'll see the order is different. Okay, so the order of globally that we've set the array label set to in this model is maintained, but all that GoldSim checks for when you copy and paste an element is that the size of the array is the same. So it checks for the name of the array label set, which is fixture type. It says, okay, this element has fixture type. Do you have fixture type? Yes, I do. Okay, good. Is it the same size? Yes. Okay, good. That's all it needs, and it pastes it in. But since it has a different order, it reordered it, and now you see that the value is different. So this is something to remember when you're copying and pasting. Also of note is when you're using our module, the contaminant transport or radionuclide transport module, you'll have a species element here. If you add species to the list, then what happens, well, actually, as soon as you add this module, then GoldSim will add 2 new array label sets automatically, and they will correspond to your array label set. So to your species. So right now, if I open this, you'll see it has them in order: species 1, 2, 3, and I can't edit them here. See, the buttons are grayed out. All I can do is change the line type and choose which ones I want to show in my outputs. But if I come into the species element here and I change the order, which, by the way, you can't change unless you come over here to species ordering and select this. And if I now change the order, you'll see it doesn't move the row down, but see the row number now is not, they're not in order. Although I can click on this row and now you see that they are changed. But anyway, we see now that it goes species 1, 3, 2. And now if we go back to the array label set, then you'll see that that is the case here in our array label set. So just keep in mind that if you're doing contaminant transport or radionuclide transport, then that is something to consider. So I'm going to now turn that back off, turning off my extra module, which removed the species elements, and it also removed my array label sets from there, which is good. Okay, so that's something about copying, pasting, new models, the different modules, and so forth. Okay, so there are some other types of elements in GoldSim that can be non-scalar. Well, most elements in GoldSim can be non-scalar, but 2 other data inputs. We have stochastic and time series. With the stochastic, you can put in vector or scalar. You cannot define, however, of matrix stochastic. Although we do have an example model on our website that allows you to actually define a matrix stochastic in a way that uses, I think it uses a looping container. If you go to our website and go to our library and then model library, let's see, it might be under arrays. Let's see. I'm going to go here, put in stochastic. Maybe I don't have one. Anyway, if you're interested in a matrix stochastic, let me know and I can send you the model. But what I did want to point you to is that we do have a set of models that all deal with arrays, and they have special functions that we don't have in native GoldSim. But these are a lot of these come from a lot of questions that our users have had about doing special things with vectors and matrices in GoldSim, and they come up often enough that we've added them to our library here. And all you need to do is click on it and then click download, and you can use the model as long as you have version 11.1. All right. So the reason that you can only define a scalar or a vector is because with matrix form of a stochastic, things get a little bit complicated, more than what we'd want to have our users deal with, so we don't have that available. On the time series, if you enter a scalar time series, then it's actually a two-dimensional table. So we have time down the rows and then the values. Well, if you specify a vector, then we have no choice but to add columns because the rows are taken up with time. So if I say vector here, housing type, let's say, if you look at the data, then you'll see that we now have 3 rows or 3 columns to represent what in our data element were rows, but since time takes up the rows, then we must go across columns. So now you're probably wondering what happens if it's matrix. If it's matrix, then we just add additional rows on top of that, which makes it look like this. So in addition to time going down the rows, we have 1 comma shower, 1 comma sink, 1 comma toilet, and etc., and then 2 comma shower, 2 comma sink, and so forth. And it just keeps on going like that. So that's how it works with the time series. Okay. The browser. So to turn the browser on and off, you click on this, or you hit F6, turn it on and off. And by default, the browser does not show the sub-items of any elements. If you want to see the sub-items, you right-click inside the browser and select Show Element Sub-items, and then you'll see that there are plus signs next to them. So for the vector, we click on that, and now you can see that it's showing all of the items and the values for them when you hover over them. Also notice that local properties appears, and these are all the global local properties that are available to the model. Also, if you click on the output port of the element, then you can see the individual values as well. Same with the matrix. Okay. You can perform when you reference a vector or a matrix in GoldSim, you can use functions that are built into GoldSim to calculate outputs on these vectors. So for example, let's say I want to calculate the mean cost for my vector data of fixture costs here. It's just one number, but it's going to be the average of all of those values in the vector. So to do that, I simply type in mean v, which means mean of vector data, like that, and I get the average of those numbers. You can get any of these functions by right-clicking in the equation field and selecting functions and going here to array operators, and it shows you a list of all the things you can do. So here's the min, vector data, it shows me the smallest number, and so forth. I can use math operators to perform perform functions on vectors and matrices. So for example, if I wanted to multiply the vector data by some scalar, then I could do that. And then this scalar data would multiply to every item in the vector. But notice the output here is a vector, so I need to change the type of this expression to match. And now all I've done is multiplied every item in that vector by 2. I can also add multiple vectors. I only have 2 of these vectors. I'm just adding the 2 together again, but you can see that I'm adding each item of the vector together, item by item. Also, if I had a constant that I wanted to multiply by a matrix, I could do the same thing for the matrix. It applies in a similar way. I can also multiply or divide a vector by a matrix. So if I have a vector here of fixtures, and let's just say these are unitless numbers. Oh, that's not as interesting. Let me do something else. There we go. So a matrix multiplied by a vector will result in a matrix. Matrix data. Oh. Like that. Okay, I can also index a vector. So for example, if I wanted to know what the third row from this vector was, I should get $4 per day. To index a vector, I use brackets. Bracket 3. And this will then return a scalar here. Okay, so this is just one number. I'm just grabbing the third row from the vector. Alternatively, I could give the name of the third row instead of the index. By the way, indexes in GoldSim on arrays are 1-based. So the first row or the first item is always indexed as 1, not 0 like some programming languages. So if I said 1 here, then this is the first row in that array. If I said 0, it wouldn't know what to do. In fact, when I run the model, it would say your specified row index of 0 is out of bounds between 1 and 4, so that's not going to work. Okay, so like I said, in addition to index numbers, I can use names. And that would also return the value that I need. Also, I may want to return an entire column or row from a matrix. So to do that, I use the asterisk. I'm going to change this to a vector. And let's say I want to just return from the matrix the values from the second column. 5, 4, 7, 8. Right there. So it grabbed all the values from the second column. This is all values, all rows from the second column. Alternatively, I could put in here housing type, and I would need to switch this around, right? So I could say 2, star, but instead of 2, star, I probably should say sync, star, just to make sure I'm using the one that I expect, like that. And now this returns all the values for sync, for the sync. So it's all columns for that one row, well, for this one row, all the values from all the columns, if that makes sense. Okay, we can also do, there are a couple of fairly specialized functions vinterp and vindex that are quite useful. So let's just go off of this data right here, this vector data. The data is going 1, 2, 4, 3. So what I could do is I could say vindex, tell me what the index is when the value is $4 per day. Oh, I need to refer to the vector, of course. Vector data. This needs to result in unitless because an index is unitless. Okay, so what this function does is it says, tell me what the index number is from this array at a value of $4 per day, and it tells me that, well, that I found that, and it always starts from the top or from the first item, and then it walks its way down when it does this. This is called an iterator. It's behind the scenes. This is iterating over the array. Okay, so what that means is if I was asking for a value that occurs a second time, which I don't have one, but let's say that this goes back down to 2 again, okay? And if I asked for the index of a 2, which one would it find, sink or dishwasher? So let me go back over here and do that. So I'm asking for the index of that array where I find a $2 per day value, and it says, oh, that's on the second row, even though in reality it was on the second and the fourth row. So that's something important to note when you're using that function. It's best if you're working with an array that's ordered data. So we do have functions in our library where we've worked out using a script. Actually, it's a little bit more complicated, but where we've said, okay, first order the data, you know, because you might have unordered data and you still want to know what row something is occurring on. Well, you need a special you need a special function to do that, and so you have to you order the data and then you find out which row that came from before it was ordered. So anyway, this is one, you know, fairly simplistic one, but usually it's yeah, you'd want to do it on an ordered data set. All right, so another one is vinterp. Oh, and sorry, one more thing. What if I said 2.5? Well, then it tells you that the approximate, well, using linear interpolation, that is, the equivalent index, decimal index, is 2.25 there. If I go off the end, so if I said 0, then it says unavailable, and when I try to run the model, it says, sorry, but that v-index lookup value is smaller than all the entries. So we don't do extrapolation on the v-index, so that's another limitation of it. Also, we could do vinterp, and this is going to need to return units here, because it's what this function does is, yeah, what this function does is it says, okay, go to that index and interpolate from that the value. Well, if you give it an index that's exactly right on a row in that vector, it will give you the value that it corresponds to that. But if I said 1.5, which is halfway between row 1 and row 2, then it will return the value that it interpolates between those two. So if I say 3.5, then it will say that it's a value of 3 because that is halfway between the value of 4 and 2. Okay, let's talk about array constructors. Let's say rather than construct an array this way with just typing in the numbers, let's say we want to do it dynamically on the fly. To do that, we type the word vector. And since I'm creating a vector, I need this this output to be defined, or this element to be defined as a vector type. And I need to make sure that whatever numbers I put into this vector constructor would result in that many values. So the fixture type array label set has 4 items in it. So I could go ahead and type 4 numbers here, and it would say, yep, that's acceptable, except that my units are off. So I'll remove the units, and now you can see that this results in 4 values, 1 through 4. I could also put in a single value in it, and it returns the same value for each of the 4 items there. I could also put in a dynamic value for each item. So I could do that by using a name that's available to vector constructors called row. But before I go into that, let's talk about what vector constructor does under the hood here. And I've mentioned iterator functions, the vinterp and the vindex. That's what they do. They iterate over the array in order to construct a number or construct values for each of the rows. Well, let's talk about what that means exactly. I'm going to create a script here, and the script element allows us to do things like write our own iterators using looping. So let's say that we want to create a new output called vector, my vector, let's say. So I'm going to define this and call it my vector, and it's going to have the fixture type array label set, and I can start it off by assigning an item at an index, or just assigning the entire array, which I'll do immediately. I'll say this is equal to a vector of zeros immediately, so that's 4 zeros that are contained in my vector. Now what I want to do is create a for loop, and with this for loop I'm going to create a variable ID that increments. Okay, so the variable ID, what it does is it's like saying row count, you could say, or just row. That row starts at a value of 1, and each loop increments by 1. And we go up until this condition is false, or while true, we're going to loop, essentially. So what I want to do is I want to loop 4 times. I want to loop until this is no longer true. I keep saying that wrong. I want to loop while this is true. All right, so now we see this. This is very similar to C, the C programming language here. So we start with row equals 1. We do that while row is less than or equal to 4. Then we increment row by 1 on each loop. Let's just inspect the row value and loop this in a model so we can see what's actually happening. Okay, within a script, if you want to refer to a value that's defined inside of a inside of a script, then you have to use this tilde symbol. If I refer to a variable that does not have that symbol, so if I said expression 1, that's a bad example. If I said scalar data, well, that's a bad example too, because it doesn't have any units. But this is actually looking outside of the script. It's looking to the scalar data that we developed earlier. And if I said my vector, it wouldn't know where to go because it's looking outside of the script. But see, we defined my vector inside the script. Well, if I put this tilde symbol here, then it knows what to look for. Well, it turns out that my vector is this is a vector, not a scalar. And what I want to do is define my vector or assign it a value. So I'm going to go up here and say my vector, and now I will assign it a value at some index. I put that in there wrong. I want to assign my vector some value at this index, which I'll say is row. So the value of row starts at 1. At that index, I want to assign it a value of, let's say 1. Okay, so let's just review again what this is doing. So I'm making an assignment to my variable that I created called my vector, and I'm going to assign it a value at the index specified here, which is changing through iteration of the for loop, starting with 1. So the first row, I'm going to give it a value of 1. On the next loop, I'm going to give it a value of 1 on the next row, and so forth. So we should be able to inspect the value of my vector as we move through this for loop. And I'm going to put in here a breakpoint by typing F9, create a breakpoint that will stop the simulation at that point. I'll run the model, and now the script opens, and we see that we are currently sitting at row 1. If I look at the value of my vector, you'll see that it has values of 0. Well, let's see. You know what I want to do is I want to see the value of the whole array. Let me see if I can see that. Let me put this change this to a vector. Okay, so I'm just going to assign the script output, the main output, to the value of my vector. Okay, there we go. Now we can see all the values by hovering over it. Okay, all I did was I made this my vector that I'm assigning values to slowly through this for loop. I'm assigning the output of this main script, which is called script 1. I'm assigning it, which is called result, to the value of my vector as I walk through this for loop. So let's see what happens now. Okay, on row 1, the value of my vector, let's see, it doesn't get assigned yet. My apologies, I have to change my script here. I have to move the result back up into here. I think that will work. Let's see what that does. There we go. Okay, so on the first iteration, we entered into line 3, and I have not yet assigned the result yet, but I have walked through one iteration, and so as I step through, then I'll get to row 4, and now what we have is that the first row is assigned a 1, and the rest are zeros. Now I'll step through again. I'll re-enter the for loop. Now we're on row 2, and now as we step down, now I've assigned the second row to a value of 1. When I step to item 4 and inspect this value, you see that the first 2 rows have a value of 1. Now I continue to step through the for loop, and now if I look at my vector, you'll see it has the first 3 values have a value of 1, and so forth. And now we finish the simulation, and now all the values have a value of 1 in there. So now what we can do is we could say, well, we could put an if statement in here. I'm going to remove that breakpoint. With an if statement now, I could say if row is equal to 2, then I could assign my vector, make an assignment at that point to be 100. Otherwise, we'll just make it 1. Let's see what we get. So if we hit row 2, then make the value 100. We could also do something like this where we say if row equals the e-day, the elapsed day, then give it a value of the elapsed day, we could say. So you can do dynamic things like this. And on the first day it gets those values. Anyway, there are lots of things you can do with that. But the point is that we can do that same thing with a vector constructor. So we could come in here with this vector and we could say if row equals 2, comma, 100, otherwise it's going to equal 1. And you see that immediately we have an answer. So this function is more compact and it's immediate. It doesn't rely on running the model to get that. But what the vector constructor does is it iterates over all of the rows of the vector, and it makes the assignments as it moves through and iterates over this. So it's all being done all in one little compact place. So that's the nice thing about a vector. Once you learn how to use vectors and matrix constructors, I can do the same thing, by the way, with a matrix. Once you do that, then you'll have the ability to do pretty complicated things with your vectors and matrices with a small amount of code there. So that's pretty nice. So something that's really nice that you can do with this is, let's say you have stochastic rainfall. Millimeters per day. Oops. This is rainfall that changes daily, and I'm correlating it to itself. And I'm running this for a long period of time, let's say. I'm just going to say 10 years. Daily data, 10 years. So when I run this model, I see rainfall that looks like this, let's say. And I suppose I should really be showing this in years. Let's see what that looks like. There we go. So that's all the years of precipitation data. Okay, and those of you familiar with reporting periods, you'll recognize this. Another thing we can do is create an annual reporting period. So what this will do is it will allow us to display results on an annual basis as well as on a daily basis. So I'm just going to change my properties of my time history to have reporting periods, and I want to compare all the plot points to the annual rainfall or cumulative rainfall. So I have two outputs here. It's actually the same output, but I'm showing it in two different ways. Now when I run this model, I can see the comparison of the annual cumulative precipitation against the daily values there. But what if we need to do post-processing in GoldSim on those annual values? Well, I can't access those annual values that are in this time history. So what I need to do now is compartmentalize or summarize or post-process that information by using a vector constructor in a stock element. So if I take an integrator here, what I can do is, since I'm running this for 10 years, I can go up here and create a array label set called simulation years 1 through 10. Now that I have that, I'm going to change my integrator to be a vector of years, like so, and it will have a units of millimeters. I'll start it out at 0, vector constructor of 0 millimeters, and now I can put in a vector constructor of my rainfall rate here. But what I want to do here is I want to say if the row equals the E year, whoops, spelled year wrong. I think it has to be +1 because the elapsed year starts at 0 and then works its way up after that. So if the row equals the current year that we're on, starting with year 1, then it's the rainfall rate. Otherwise, it's 0 millimeters per day, like that. So what this is saying is it's building a vector, okay, on the first year, which would be row 1, we're going to accumulate the rainfall. On the next year, on year 2, then we're going to we're only going to accumulate the rainfall on row 2. Otherwise, we don't care. Only if we're on the only if the current row we're looking at equals the current year we're looking at. So now what we can do is run this model, and I can look at an array view of the annual results there. So, whoops. So let's just create an array view plot of the integrator there. So there's that plot, and I'll kind of move that down out of the way, and then we can put this one over here so you can kind of see. Well, I don't have a lot of space here, but you can kind of see the comparison there. But the annual values are over here on the right side in this time history. So those should be comparable. But now that we have this in an array, I can do things to it, right? So now I can say, what is the average annual of all the annuals with an expression here. So I can go integrator, whoops, mean V of the integrator, for example. And then I don't know that until I run it. So I would run this model, and then I would know the mean. But interestingly, since you can put in submodels in GoldSim, I could pre-process all of this, right, before I run the model. So I could go in here and I could say, the main model only needs to run for 10 days, but this model I want to run for 10 years. So I could put this submodel in here, and I could say, run this for 10 years on a yearly time step with all the same stuff we put in here before, right? So this is major period of 1 year, and everything's the same. Let's see, set that all up the same. We don't, yeah, I want that. Okay, so then I can take all of this, paste there. And then this model here would only run for the 10 days that we had earlier. Like that. Okay. And now what I can do is expose the output of the rainfall here as a final value. I don't want the statistic or anything. I'm just going to say the last calculated from the submodel, which would then let me access this using, I think I can just plot it right from here. The output there. And this is the rainfall there. So now when I run this model, do I get the values? Yes. I think the values are different because we ran a new simulation. This is a totally different simulation with a randomized numbers there. So anyway, the reason I put this into a submodel is that now we could run for 10 days with something that was pre-processed at the beginning of the simulation. So before the simulation even begins, we could now use these numbers as inputs to this main model here. So if you want to see the results inside, I could click on this Save Results inside so that when I run the model, I can go in here and I can see what those results are. And you can see that they're still comparable. So keep in mind that we have results that look different than before because this is essentially a new model. I pasted that stochastic. It's going to act differently now that I've put it into a different model. Okay, so that concludes the Arrays in GoldSim webinar. Thank you very much for joining. I hope this was useful. I appreciate any feedback, and I will be taking questions at this time.